let's find the solution to this system of equations using the elimination method. Remember, there are multiple ways to use the elimination method. This is just one example of how to use the elimination method to solve this particular system. If you'd like to see another example, we have a tutorial that'll show you. But here's one example. We want to start by writing out our equations separately. Well, if we look, we see both of our equations have already been written on the board, so we can just use those. In step number 2, we want to use the elimination method to combine our two equations together in such a way that one of the variables is eliminated. To do this, we want to use addition, subtraction, or multiplication. Our equations are 4x minus 2y equals 4 and 2x plus y equals 6. Now for this example, let's try to eliminate the x variable. So we have 4x and 2x. Well, if we were to just add these two equations together, we would not eliminate x. So we need to do something to one or both of these equations in order to eliminate x. To eliminate a variable, those variables have to have the same coefficient but opposite signs. Here, we have a coefficient of positive 4. And here we have a coefficient of positive 2. Well, both of them have a positive sign. So that means one of these equations needs to become negative in order to eliminate x. Also, 4 is not equal to 2. But if we were to take 2 and multiply it by 2, we would get 4. So let's take equation 2 and multiply it by 2. And since one of these equations needs to be negative, let's multiply equation 2 by a negative 2. Now let's combine these two equations together. We'll rewrite equation 1, and then we need to simplify what we did to equation 2. So we need to distribute in this negative 2 to every term in our equation. When we do, we get negative 4x minus 2y equals negative 12. Now we can combine them together. Notice, though, that we lined up our variables, our equal sign, and our numbers. If you set up your equations like this, it will be a lot easier to combine them. Now when we combine, we have 4x minus 4x. Hey, our x's canceled out just like we wanted. Then we have a negative 2y and a negative 2y. Well, those combine to be negative 4y. Then we bring down our equal sign, and 4 minus 12 is negative 8. Now look at what happened. By taking equation 2 and multiplying it by negative 2, and then combining our equations together, we eliminated x and are just left with our y variable. When we solve for y, we get that y equals 2. Hey, we have half of our solution. Y equals 2. All we need to do to find the rest of our solution is to find x. So in step number 3, let's find x. To do this, we need to take the value we just got for y and plug it into both of our original equations and solve for x. So let's take our first equation. When we substitute in 2 for y, we get 4x minus 2 times 2 equals 4. Well, 2 times 2 is 4, and if we add 4 to both sides, we get that 4x equals 8, or x equals 2. We got a value for x. So x equals 2. Now, let's make sure we get the same x value when we plug in our y value into our second equation. So we have 2x plus y equals 6. Substituting in y, we have 2x plus 2 equals 6, or 2x equals 4. Again, we get that x equals 2. We got x equals 2 in both cases. So that means that x is 2 and y is 2. So we have our solution. The solution to this system is the ordered pair 2, 2. 2, 2 satisfies this system. If we take that ordered pair and plug it in for x and y into both of our original equations, we will get a true statement in both cases. And since 2, 2 is the only solution to this system, the system is called consistent and independent. This was just one example of how to use the elimination method to solve a system.